Hello students, today we are going to study inverse trigonometric functions from class 12. Trigonometry is rather confusing many a times, so watch the video till the end to get a detailed understanding of the chapter. First, let us recall what is an inverse function. If f is a function from x to y such that fx is equal to y. If this function is 1, 1 and onto, then we can define a unique function, say g, which will be from y to x such that g of y equal to x, where your x belongs to x and y is equal to f of x. Here if you see, the domain of g is same as the range of f and the range of g is same as the domain of f. So the function g is called the inverse of f and is denoted by f inverse. So g will also be 1, 1 and onto. Now you know g is equal to f inverse, so f will be equal to g inverse. G inverse is, g is f inverse, so g inverse is f inverse of inverse and that will always be equal to f. Also, when you take composition of functions, f inverse of f of x is f inverse of f of x, which is f inverse of y, which is same as x. So f inverse of f is x and similarly f of f inverse is y. G and f are 1, 1 and onto functions. To understand the inverse trigonometric functions, first we will take the sine function. First we will understand the sine function and then inverse of sine. Now we know that the domain and range of sine function are respectively minus infinity to infinity and minus 1 to 1. The domain is minus infinity to infinity and the range is minus 1 to 1. Now if we restrict its domain to minus pi by 2 to pi by 2, then in this domain it will become 1, 1 and onto with the range minus 1 to 1. Now in fact, this sine function, if you restrict to any of the intervals, say minus 3 pi by 2 to pi by 2, minus pi by 2 to pi by 2 or pi by 2 to 3 pi by 2 and so on, in all of its this restricted domains it will be 1, 1 and the range will be minus 1 to 1. So now for each of them we can define the inverse function. We define the inverse of sine function in each of these intervals and we generally denote it by sine inverse. It is sometimes also called arc sine function. Now the sine inverse function. Sine inverse is a function whose domain will now become minus 1 to 1 and range could be any of the intervals, say minus 3 pi by 2 to pi by 2, minus pi by 2 to pi by 2, pi by 2 to 3 pi by 2 and so on. In fact, you know that sine inverse will be just the domain and range will just be the opposite then of sine. So now corresponding to each such interval, we get a branch of the sine inverse function. For example, the branch with the range minus pi by 2 to pi by 2, this is called the principal value branch, whereas other intervals as range give the different branches of sine inverse. The main branch, the principal value branch will be minus pi by 2 to pi by 2. So now as a function, sine inverse will be a function from minus 1 to 1 to the interval say minus pi by 2 to pi by 2. This is one of the intervals. We can take any of the intervals, but this particular interval will give you the principal value branch. Now what does that mean? See, if you see the graph, sine inverse of minus 1, what will it be? It will be minus pi by 2. Why? Because what will be sine of minus pi by 2? It will be minus 1. Same way sine of pi by 2 is 1. So sine inverse of 1 will be pi by 2. So if you see the graph for sine inverse, then you will get the point say 1 pi by 2, minus 1 minus pi by 2 in the principal value branch and then you can have the other values. So this is basically the sine inverse function and actually if you see the graph of y is equal to sine inverse can be obtained just by reversing or interchanging the x and y axis for the graph of y is equal to sine inverse. Now other things which hold true will be sine of sine inverse of x will be x. Why? Because they are functions and just now we have seen f of f inverse and f inverse of f. Similarly sine of sine inverse of x will be x and sine inverse of sine of x will be x. So now if y is equal to sine inverse of x, then we write sine y is equal to x. This is the inverse function. And the graph, again I am repeating, the graph of y is equal to sine inverse can be obtained from the graph of y is equal to sine x by just interchanging the x and y axis. So like we have just now seen, these are the domain and range for the sine and sine inverse function. Sine function, principal domain is minus pi by 2 to pi by 2, domain minus infinity to infinity, and range minus 1 to 1. And for sine inverse, it will be the reverse. The principal domain will become the range of sine inverse minus pi by 2 to pi by 2, and the range minus 1 to 1 will be the domain of sine inverse, which is minus 1 to 1. Now, like the sine and sine inverse function, we try to see the other trigonometric functions and its inverse. So now cos and cos inverse. Cos function, the principal domain will be 0 to pi. Like for sine, the principal domain was minus pi by 2 to pi by 2. Same way for cos function, the principal domain is 0 to pi. The domain can be minus infinity to infinity. And what will be the range? Range will obviously be minus 1 to 1, because cos value you can get any value between minus 1 to 1. So range is minus 1 to 1. Now for cos inverse function, just remember you are interchanging. That means the range of cos function will be the domain of cos inverse function, minus 1 to 1. And the principal domain of cos function will be the range of cos inverse function, which is 0 to pi. Correct? So cos function and cos inverse. Also, if you see the graph, then in the first graph it is for the cos function, and the graph is in bold for the principal value branch. From that you get the cos inverse function. So if you know the cos function, you will also know the cos inverse function. It is just obtained by interchanging the x and y axis. Again, cos inverse is also called arc cos. So this is cos and cos inverse function. Now sec and sec inverse functions. Sec is 1 upon cos. So now first of all, for the sec function, the principal domain will be 0 to pi minus pi by 2. Why? Because you know that 1 upon 0 is not defined. Cos pi by 2 is 0, so it cannot take the value pi by 2. So the principal domain for the sec function is 0 to pi minus pi by 2. The whole domain will be r minus, it cannot take values like pi by 2, 3 pi by 2, where cos is 0. Correct? So the domain for sec function is r minus 2n plus 1 pi by 2. Range. What will be the range? Range can be minus infinity to 1 union 1 to infinity, because it will not take the values between minus 1 to 1. So range is r minus minus 1 to 1 or minus infinity to 1 union close interval 1 to open interval infinity. Now for sec inverse function, it will just be the opposite. The range of sec function will be the domain of sec inverse function, which is r minus minus 1 to 1. And the principal domain of sec function will be the range of sec inverse function, which is 0 to pi minus pi by 2. Cosec and cosec inverse functions. Cosec is 1 upon sine. So the principal domain will be minus pi by 2 to pi by 2 minus 0, because 1 upon 0 is not defined. Sine 0 is 0. So it cannot take the value 0. So the principal domain will be minus pi by 2 to pi by 2 minus 0. Correct? So once you know the domain and range for sine and cos functions, other functions you can understand and get it. Now the domain. Domain will be r minus n pi, because for pi, 2 pi, 3 pi, for all those values cosec will not be defined. So domain is r minus n pi. Range will be r minus minus 1 to 1 or minus infinity to 1 union 1 to infinity. So it will not take the values in between minus 1 to 1. Cosec inverse just by reversing. So the range of cosec will be the domain of cosec inverse, which is r minus minus 1 to 1. And the principal domain of cosec will be the range of cosec inverse, which is minus pi by 2 to pi by 2 minus 0. Now tan and tan inverse functions. First of all, tan function. Tan means sine upon cos. Principal domain would be open interval minus pi by 2 to pi by 2. Please take care, it is open interval minus pi by 2 to pi by 2. And the domain is r minus 2n plus 1 pi by 2. Why? Because for example, at pi by 2, tan function is not defined. Correct? It will be of the type, say, sine pi by 2 upon cos pi by 2, which is 1 upon 0, which is not defined over here. So, remember, it is open interval minus pi by 2 to pi by 2 and the domain is r minus 2n plus 1 pi by 2. Because at pi by 2, 3 pi by 2, all these places tan is not defined. Range is minus infinity to infinity or r. For tan inverse function, the domain will be range of tan, which is r, and the range will be the principal domain of tan, which is minus pi by 2 to pi by 2 open interval. Once again, if you see the graphs, they are just obtained by interchanging the axes. Similarly, we have cot and cot inverse. Cot function principal domain is 0 to pi. Cot is cos upon sine. And the domain is r minus n pi. Because at pi, 2 pi, minus pi, it is not defined. Cos upon sine. So once again, say at pi, it will be minus 1 upon 0, which is not defined. Correct? So the principal domain is 0 to pi open interval. Domain is r minus n pi. Range is r or minus infinity to infinity. For cot inverse, it will just be the opposite. Domain will be the range of cot, which is r, and the range of cot inverse is the principal domain of cot, which is open interval 0 to pi. Now we have listed the domain and range for all the trigonometric and inverse trigonometric functions. This chart should be there in your mind always. Now for sine, see, we have listed the principal domain and range, and you can see for the inverse function, the principal domain will be the range and the range of the trigonometric function will be the domain of the inverse function. So this is just the list which we have just now seen: sine, cos, tan, cosec, sec and cot. Now this chart is again for the domain and range of trigonometric and inverse functions, but over here I have just listed the whole domain for the trigonometric functions, not the principal domain only, and the inverse trigonometric functions. This can be asked in the objective type of questions. Now this chart is again for the domain and range of trigonometric and inverse functions, but over here I have just listed the whole domain for the trigonometric functions, not the principal domain only, and the inverse trigonometric functions. This can be asked in the objective type of questions. We have understood the inverse trigonometric functions. Before going to the examples, just remember this thing: sine of sine inverse of x will be x for any x belongs to minus 1 to 1, and similarly sine inverse of sine of x will be again x belongs to minus pi by 2 to pi by 2. And similarly, this results will follow for other trigonometric functions for the suitable values of the domain. Now, these are the values of the trigonometric functions for some basic angles. This chart should be memorized thoroughly. Now, the first example, try to understand carefully each of the examples. Find the principal value of the following. First one, cot inverse of minus 1 upon root 3. Now for this type of examples, first of all, assume y is equal to cot inverse of minus 1 upon root 3. So what do you get? Cot y is minus 1 upon root 3. Now as I told you, just memorize the previous table. So you know cot pi by 3 is 1 upon root 3. So minus 1 upon root 3 is minus cot of pi by 3. Now also you know that for any angle x, minus cot x is cot of pi minus x. Second quadrant ASTC, correct? So cot of pi minus x is minus cot x. So instead of minus cot pi by 3, now I am writing cot of pi minus pi by 3. So that is same as cot of 2 pi by 3. Now the range of principal value branch of cot inverse just now we have seen is 0 to pi, and our 2 pi by 3 lies in this range. So fine, no problem. So what we have obtained is cot of 2 pi by 3 is minus 1 upon root 3. That means cot inverse of minus 1 upon root 3 is 2 pi by 3. Hence the principal value of cot inverse of minus 1 upon root 3 is 2 pi by 3. Second example, find the principal value of cosec inverse 2. Again same technique, let y is equal to cosec inverse of 2. So cosec y is 2. Now again from the previous table, you know that cosec of pi by 6 is 2. So now what we have obtained, also we know that the range of principal value branch of cosec is minus pi by 2 to pi by 2. Our pi by 6 lies in this range. So find cosec of pi by 6 is 2. Hence the principal value of cosec inverse of 2 is pi by 6. Example 2. You have to find what is tan inverse of root 3 minus sec inverse of minus 2. Now root 3 is given. So you know that tan of pi by 3 is root 3. So tan inverse of root 3 is pi by 3. Second term. You know that sec of pi by 3 is 2. Correct? So minus sec of pi by 3 is minus 2. Okay, we are just having the minus sign on both the sides. So now minus sec pi by 3 is again for any angle theta, minus sec theta is sec of pi minus theta. Correct? Just now like in the previous example, same way, just remember these things. ASTC second quadrant, pi minus theta, sec of pi minus theta is minus sec theta. So instead of minus sec pi by 3, I am writing sec of pi minus pi by 3, which is equal to sec of 2 pi by 3. So now our question which is given, that will be equal to pi by 3 minus 2 pi by 3, or which is equal to minus pi by 3. Example 3, you have to prove the following two equations. First one, prove that 3 sin inverse of x is equal to sin inverse of 3x minus 4x cubed. Now see, we are going to use the trigonometric identities, the whole chart, all the formulas for trigonometric identities you should remember. So looking at the example, as you practice more, you will come to know what value you are going to take, or what assumption you are going to take for x, so that you can prove the given equality. Here, first of all, let us take x is equal to sin theta. You will understand why we are taking x is equal to sin theta. Our right hand side is sin inverse of 3x minus 4x cubed. So, sin inverse of x is sin theta. So, it is sin inverse of 3 sin theta minus 4 sin cube theta. Now, remember the formula. The formula of sin 3 theta is 3 sin theta minus 4 sin cube theta. We are using this formula. So, our right hand side will be sin inverse of sin of 3 theta, and you know sin inverse and sin applied will give you the angle which is equal to 3 theta. So now 3 theta means 3 sin inverse of x, which is equal to our left hand side. So we have proved this using the identity sin 3 theta is equal to 3 sin theta minus 4 sin cube theta. Now I think it is clear why we should take x is equal to sin theta. Second one, you have to prove 3 cos inverse of x is equal to cos inverse of 4x cube minus 3x. Here you take your x as cos theta. So our right hand side is cos inverse of 4 cos cube theta minus 3 cos theta. Now use the identity cos 3 theta is 4 cos cube theta minus 3 cos theta. Hence our right hand side is cos inverse of cos 3 theta, which is equal to 3 theta, or 3 cos inverse of x, which is the left hand side. So we have used this identity and proved the equations. We are discussing different types of examples. The fourth example says that you have to write the following functions in the simplest form. The first function which is given is tan inverse of root of 1 plus x square minus 1 upon x. Now here again I am saying you should know all the identities, and just based on that you have to make your assumption. So let x is equal to tan theta. So left hand side is tan inverse of root of 1 plus tan square theta minus 1 upon tan theta. What is 1 plus tan square? It is sec square. So it will become tan inverse of sec theta minus 1 upon tan theta. Sec is 1 upon cos, tan is sin upon cos. So simplification, you will get tan inverse of 1 minus cos theta upon sin theta. Now use the identities over here. You know identity which is cos of double the angle, means cos 2 theta is equal to 1 minus 2 sine square theta, and sine of 2 theta is 2 sine theta cos theta. These are called the identities for double angle. So over here, instead of cos theta, I am going to write 1 minus 2 sine square theta by 2. But 1 minus 2 sine square theta by 2 is 2 sine square theta by 2. The denominator is sine theta. Instead of sine theta, consider that as a double angle. So instead of sine theta, I am going to write 2 sine theta by 2 cos theta by 2. So now our left hand side on simplification will be tan inverse of tan theta by 2. So what we have obtained is tan inverse of tan theta by 2, which will be equal to obviously theta by 2. What is your theta? Theta is tan inverse of x. So theta by 2 is half of tan inverse of x. So the simplest form will be half of tan inverse of x. Next, write this function in the simplest form. Tan inverse of x upon root of a square minus x square mod x less than a. Now it is like the previous one, but over here you are having tan inverse of x upon root of a square minus x square. Now here you need to take x is equal to a sine theta, correct? Now see why we are taking, as I told you, just by practice it will be clear that what you have to take as x. X is equal to a sine theta means x by a is sine theta. So your theta is sine inverse of x by a. So left hand side is tan inverse of a sine theta, correct? X is over here a sine theta. So tan inverse of a sine theta upon root of a square minus x square. X square is a square sine square theta. So tan inverse of a sine theta upon root of a square into bracket 1 minus sine square, which is cos square. So the left hand side will become tan inverse of a sine theta upon a cos theta. So a gets cancelled, so it is tan inverse of tan theta. Now you will get the reason why we had taken x is equal to a sine theta, because just see, if you look at the example, the denominator is of the type a square minus x square. So you know that 1 minus sine square is cos square and 1 minus cos square is sine square. So on basis of that you have to make the assumption. So our left hand side is tan inverse of tan theta, which is theta, and what is theta? Sine inverse of x by a. So the simplest form is sine inverse of x by a. Example 5. Find the values of each of the following expressions. First is sine inverse of sine 2 pi by 3. Now again over here, see, 2 pi by 3 will not be in the principal value branch. So you have to first convert it. So now 2 pi by 3 you can write as pi minus pi by 3. And you know that sine of pi minus x is sine x. You already know this, but again I am repeating, when you are doing pi minus the angle, the trigonometric function will not change. If you do pi by 2 minus the angle, the trigonometric function will change. Also pi minus x means in the second quadrant where sine is positive. So sine of pi minus x is basically sine x. Using that we will get sine inverse of sine of, instead of 2 pi by 3, pi minus pi by 3, so which is equal to sine pi by 3. So sine inverse of sine pi by 3 is pi by 3. So the value of the given function is pi by 3. Second one, find value of sine of pi by 3 minus sine inverse of minus half. Now sine of pi by 3 minus sine inverse of minus half. Why? See, now I have given the explanation. First thing is, you know that sine of minus x is minus sine x. Cos is even function, sine is odd functions. Cos of minus x is cos x, but sine of minus x is minus sine x. I am just revising these concepts of the previous standards. So first thing what we are using is sine of minus x is minus sine x. Another thing is sine inverse of minus half. What will it be? Sine inverse of minus sine pi by 6, because half is sine pi by 6. Sine inverse of sine of minus pi by 6. Why? Again sine of minus theta is minus sine theta. So now what is this? This is equal to minus pi by 6. So this is how in the left hand side, when you simplify sine inverse of minus half, that is minus pi by 6. So now it is sine of pi by 3 minus plus pi by 6. So that is sine of 3 pi by 6. That is sine of pi by 2, which is equal to 1. So the value of the expression is 1. Find the value of cos inverse of cos of 13 pi by 6. Again I am telling you 13 pi by 6 is not in the principal value branch. So you have to first convert it. 13 pi by 6 can be written as 2 pi plus pi by 6. Now again cos inverse of cos of 2 pi plus pi by 6. Cos is even function, so cos of 2 pi plus pi by 6 is cos pi by 6. So it will be equal to cos inverse of cos of pi by 6, which is equal to pi by 6. Tan of sine inverse of 3 by 5 plus cot inverse of 3 by 2. So now first of all let us simplify both the terms individually. Sine inverse of 3 by 5 let it be x and cot inverse of 3 by 2 let it be y. So sin x is 3 by 5. Now if sin x is 3 by 5, then what will be cos x? Cos square is root of 1 minus sin square. So cos x will be 4 by 5. So tan x will be sin by cos, which will be 3 by 4. Similarly, cot y is 3 by 2. So tan y will be the inverse 2 by 3. Now it will be clear why we had taken this. So our left hand side is basically tan of our x plus y. Correct? Now tan of x plus y, use the formula trigonometric identities. Sum of two angles. Tan of sum of two angles. Tan of x plus y is tan x plus tan y upon 1 minus tan x into tan y. Just put the values of tan x and tan y, and on simplification you will get this equal to 17 by 6. So the value of the given expression is 17 by 6. Example 6. Prove that tan inverse of root x is equal to half cos inverse of 1 minus x upon 1 plus x. X belongs to 0 to 1. Now tan inverse of root x, let it be equal to theta. Correct? So what will be tan theta? Root x. Tan theta is root x, so x is tan square theta. Our right hand side, it will be easy to go from right hand side to the left hand side. So let us simplify that. Right hand side is half of cos inverse of 1 minus x upon 1 plus x. So that is equal to half of cos inverse of x is tan square theta. Just put the values. Now again use the identity. Remember these identities, trigonometric, all the formulas are very important, and we are also going to make a video for that. So do subscribe to the channel for that. Cos 2 theta in terms of tan can be written as 1 minus tan square upon 1 plus tan square. So your right hand side will be half of cos inverse of cos 2 theta. Correct? So that will be half of cos inverse of cos is 2 theta. So that is equal to theta, which is equal to tan inverse of root x. Correct? So that is equal to our left hand side. Next important example. Prove that tan inverse of root of 1 plus x minus root of 1 minus x upon root of 1 plus x plus root of 1 minus x is equal to pi by 4 minus half cos inverse of x. Now remember, these type of examples you can be doing it in any of the ways. Obviously one way would be a shorter way, but in case if you do it by any of the ways and you get the answer, it is fine. So here I have shown both the ways. First step is, so let us simplify. Let x is equal to cos 2 theta. This also you will understand why we have taken as we proceed further. So let x is equal to cos 2 theta. So obviously 2 theta is equal to cos inverse of x. Theta is half of cos inverse of x. Keep that aside. Let us start from the left hand side. Tan inverse of root of 1 plus x. Now instead of x everywhere, just put cos 2 theta. Now we will use the two important identities, cos 2 theta in terms of cos and sine. So cos 2 theta, these are called the double angle identities. Cos 2 theta is 2 cos square theta minus 1, or cos 2 theta can also be written in terms of sine as 1 minus 2 sine square theta. So for the numerator, first term is root of 1 plus cos 2 theta. So 1 plus 2 cos square theta minus 1. 1 gets cancelled. Root of 2 cos square theta is root 2 into cos theta. Second term is root of 1 minus cos 2 theta. Here you will be using cos 2 theta is 1 minus 2 sin square theta. So it will be simplified as 1 minus 1 minus minus plus 2 sin square theta, which is taking the root, it is equal to root 2 sin theta. Similarly, the denominator. Now just divide the whole thing by root 2 cos theta. So our left hand side is simplified as tan inverse of 1 minus sin theta by cos theta, which is tan theta upon 1 plus tan theta. This is the first step simplification of the left hand side. Now for getting the first step simplification, I have also shown another method. Obviously first method might seem to be a smaller one, but in case if you proceed by this method also you are going to get the same step. So now in this method what we are doing is we are multiplying by the conjugate and first simplifying the angle in between. So tan inverse of whatever is given over here, that part we are first simplifying. So you can just see you are multiplying by the conjugate. Just use the result a square minus b square is a minus b into a plus b. So on simplification, first step you will get tan inverse of 1 minus root of 1 minus x square upon x. Now you put x is equal to cos 2 theta. So it will be tan inverse of 1 minus sin 2 theta upon cos 2 theta. Here you will use the identities of cos double angle of sine and cos in terms of tan. So you know that cos 2x is 1 minus tan square x upon 1 plus tan square x, and sine 2x is 2 tan x upon 1 plus tan square x. So put these values on simplification. You will be getting the left hand side again as tan inverse of 1 minus tan theta upon 1 plus tan theta. So this is another way. By chance you are proceeding by this way, you are also going to get the left hand side in simplified form as tan inverse of 1 minus tan theta upon 1 plus tan theta, like the previous one. Now the second step. So by any of the ways you do, you are going to get your left hand side as tan inverse of 1 minus tan theta upon 1 plus tan theta in the simplified form. Now what is 1? You know that tan pi by 4 is 1. So we are going to use the identity tan of any angle alpha minus beta is equal to tan alpha minus tan beta upon 1 plus tan alpha into tan beta. So in the numerator, instead of 1, put tan pi by 4. So tan pi by 4 minus tan theta upon 1 plus tan theta means I can write it as 1 into tan theta. Instead of that one, put tan pi by 4. So now it is tan inverse of tan of pi by 4 minus theta. So that is pi by 4 minus theta, which is pi by 4 minus theta. You know it is half of cos inverse of x. Hence this is equal to our right hand side. Example 8. Prove that tan inverse of 1 upon 5 plus tan inverse of 1 upon 7 plus tan inverse of 1 upon 3 plus tan inverse of 1 upon 8 is equal to pi by 4. Now here we are going to use this identity tan inverse of x plus tan inverse of y is equal to tan inverse of x plus y upon 1 minus xy. So first group the first two terms. This is a simple use of the identity. First group the first two terms and then the second two terms. Apply the above formula. So you will get it as tan inverse of 12 by 34, which is tan inverse of 6 by 17. Second term is plus tan inverse of 11 by 23. Again use the above formula and group the terms. So you will be getting this as tan inverse of 325 by 325, which is tan inverse of 1. You know that tan inverse of 1 is pi by 4. Why? Because tan pi by 4 is 1. So this is equal to pi by 4, our right hand side. Example 9. Solve the given equation. Tan inverse of 1 minus x upon 1 plus x is equal to half tan inverse of x. Here again, looking at the example, take x is equal to tan theta. So obviously your theta is tan inverse of x. Now left hand side, tan inverse of 1 minus, instead of x put tan theta. So 1 minus tan theta upon 1 plus tan theta. Again, like the one of the previous examples, you know tan pi by 4 is 1. So instead of 1 put tan pi by 4 and then use the identity of difference of two angle. Tan of x minus y is tan x minus tan y upon 1 plus tan x into tan y. So the left hand side will become tan inverse of tan of pi by 4 minus theta, which is equal to pi by 4 minus theta. Right hand side. Right hand side is half tan inverse of x. So half tan inverse of tan theta, which is half of theta. Solve means you have to get the value of x. So now equate your left hand side and right hand side. So it will be pi by 4 minus theta is equal to half theta. which will give you on simplification theta as pi by 6. So theta is pi by 6, but what is theta? Tan inverse of x. So tan inverse of x is pi by 6. That will give you x as 1 upon root 3. Why? Because you know tan pi by 6 is 1 upon root 3. So the solution of the given equation means the value of x which you have obtained is 1 upon root 3. This is the solution. Next example. Sine inverse of 1 minus x minus 2 sine inverse of x is pi by 2. Then what will be the value of x? You have to solve this equation and choose from the given options. But remember over here, the first option has 0 and half, while the third option is 0 and the fourth option is half. That means you have to get the exact value of x. First thing is let x is equal to sine theta. So obviously theta is sine inverse of x. Left hand side, sine inverse of 1 minus x minus 2 sine inverse of x. In that, first of all, in the second term, instead of x, when you put your sine theta, it will be 2 sine inverse of sine theta, which is theta. So now your left hand side will be sine inverse of 1 minus x minus 2 theta, which is equal to pi by 2. This is given to you, correct? Solving means you are given this equation, you have to get the value of x. So now what we have obtained is sine inverse of 1 minus x minus 2 theta is pi by 2, or sine inverse of 1 minus x is 2 theta plus pi by 2. That means sine of sine inverse of 1 minus x, you are applying sine on both the sides, is sine of pi by 2 plus 2 theta. Now you know that when you apply pi by 2 to a function, the function changes. So it will become cos 2 theta, correct? And pi by 2 plus 2 theta, second quadrant, you know that it will be cos 2 theta. So 1 minus x is cos 2 theta. 1 minus x is 1 minus, instead of cos 2 theta, I am using the identity cos 2 theta is 1 minus 2 sine square theta. So 1 minus x is 1 minus 2 sine square theta, or it is 2 sine square theta minus sine theta equal to 0. Now this equation, take out sine theta 2 sine theta minus 1 is equal to 0, means either sine theta is 0 or 2 sine theta minus 1 is 0. So when sine theta is 0, your x should be equal to 0. Why? Because you know that sine of 0 is 0. Second case, sine theta is half. Sine theta is half. That means what is sine theta? Your value of x. So x is equal to half. So possible values of x are 0 or half. Now the main part. See, you have got two values of x. You have got x is equal to 0, x is equal to half. Now if I put this value x is equal to 0 in the equation, the left hand side is sine inverse of 1 minus x minus 2 sine inverse of x. Put x equal to 0. So it is sine inverse of 1 minus 2 sine inverse of 0. Sine inverse of 1 is pi by 2. Why? Because sine pi by 2 is 1. And sine inverse of 0 is 0. So it is pi by 2 minus 2 into 0, which is equal to pi by 2. This is equal to your right hand side. So equation is satisfied. X is equal to 0 is the correct value. But now if you put x is equal to half, the left hand side will become sine inverse of half minus 2 sine inverse of half. That means minus sine inverse of half. Any x minus 2x is minus x. So it is minus sine inverse of half. What is that? Sine pi by 6 is half. So this will be equal to minus of pi by 6. Is minus pi by 6 equal to pi by 2? No. So the equation is not satisfied. So x is equal to half will not be a root. So even if you have obtained two values of x, the value of x which satisfies the given equation is x is equal to 0. So your correct answer is answer C, which is x is equal to 0. So students, we have discussed inverse trigonometric functions and all the examples explained thoroughly. Please like and share the video and subscribe to the channel for maths of class 12th.